431 kilometers per hour. That's the speed at which a French test driver named Pierre-Henri Raffinel sat inside a machine screaming across a stretch of German tarmac in the summer of 2010, faster than any road-legal production car had ever traveled before. At that velocity, the car's tires were spinning fast enough to generate centrifugal forces capable of tearing them apart in minutes. This is the story of how a small team of engineers refused to accept that a car could not be both brutally fast and comfortably civilized, and how, in doing so, they built something that broke the laws of what was thought possible on four wheels. To understand how absurd this achievement was, you have to go back to the late 1990s, when the Volkswagen Group, under the leadership of an engineer named Ferdinand Piëch, went shopping for prestige. Piëch was a man obsessed with engineering extremes, the grandson of Ferdinand Porsche himself, and he had a habit of scribbling ambitious specifications on napkins and handing them to his engineers as though they were simple requests. In 1998, Volkswagen acquired the rights to the Bugatti name, a legendary mark that had produced some of the most elegant and dominant race cars of the early 20th century before fading into dormancy after the Second World War. Piëch wanted to resurrect it, but not with a modest sports car. According to accounts from those close to the project, he set an almost impossible target, a car that could exceed 1,000 horsepower, reach a top speed beyond 400 kilometers per hour, and still be quiet and comfortable enough to drive to the opera. Engineers who heard the brief reportedly thought it was a joke. It was not. The challenge Piëch had posed ran headlong into the brick wall of physics. At speeds beyond 300 km per hour, aerodynamic drag increases exponentially, meaning the horsepower required to go faster grows at a punishing rate. Engine heat becomes a nightmare to manage. Tires begin to behave unpredictably under massive centrifugal load. Downforce, needed to keep a car planted on the road, tends to also increase drag, creating a vicious tug-of-war between stability and speed. No production road car had ever been engineered to survive, let alone thrive, in that kind of environment. The team charged with solving this problem was led first by a small group of Volkswagen engineers, and the concept car that emerged, revealed at the 1999 Geneva Motor Show under legendary designer Giorgetto Giugiaro's influence and later refined by the design team through several concept iterations, hinted at what was coming. But turning a concept into a functioning, sellable machine took years of grinding, expensive development. At the heart of the challenge sat the engine. Engineers eventually landed on a configuration that sounds almost like science fiction, a W16, essentially two narrow-angle V8 engines fused together, fed by not one, not two, but four turbochargers. This engine would eventually produce 1,001 metric horsepower, an 8-liter, 16-cylinder monster mounted just behind the cabin. But raw power was only the beginning of the problem. An engine producing that much force generates immense heat, so much that the Veyron needed 10 radiators just to keep everything from cooking itself alive, radiators for the engine, for the transmission, for the air conditioning, for the differentials, an intricate plumbing system of coolant lines snaking through the car's bodywork like a circulatory system built for a mechanical heart. The transmission posed another nightmare. A conventional gearbox would have been shredded by the torque this engine produced, so engineers developed a dual-clutch 7-speed transmission capable of changing gears in milliseconds while still handling forces that would destroy lesser components. Getting the power to the ground required all-wheel drive, distributing that violence across 4 contact patches instead of 2, because no rear tires alone could put down that much force without simply spinning into oblivion. Then came aerodynamics, arguably the most delicate puzzle of all. The car needed to slice through air with minimal resistance at top speed while generating enough downforce to stay glued to the road, and it needed to do this while remaining stable enough that an ordinary skilled driver, not a professional racer, could pilot it safely. Bugatti's solution was a car that physically transformed itself depending on the situation. At normal speeds, the Veyron rode at one ride height with a modest rear spoiler. But as the car accelerated past 200 km per hour, hydraulics lowered the entire body closer to the ground while the rear wing rose and tilted to generate downforce, the front splitter adjusted, and the car reconfigured its own shape in real time to survive what was coming. This was not decoration. It was survival engineering happening automatically, hidden beneath the surface of a car that, to a casual observer, simply looked like an extraordinarily beautiful, teardrop-shaped Grand Tourer. By the time the production Veyron 16.4 was unveiled in 2005, Volkswagen and Bugatti had poured staggering sums into its development. Estimates over the years suggested the company lost significant money on every single unit sold, even at a price tag north of $1 million, because the engineering cost of solving these physics problems dwarfed what any customer could reasonably be charged. But money was almost beside the point. This was a statement car, a rolling proof of concept that a small, obsessive group of engineers, pushed by one man's stubborn refusal to compromise, could do what the rest of the automotive world considered impossible. And then came the moment of truth. In 2005, the Veyron was independently tested and confirmed to reach a top speed of 407.5 km/h, making it, at that time, the fastest street-legal production car in the world, smashing the previous benchmarks held by cars like the McLaren F1. It was validated by Volkswagen's own test track in Aerodynamics, a facility with a straight long enough and secure enough to attempt speeds that would be suicidal almost anywhere else on Earth. But Bugatti was not finished chasing the ceiling. Engineers continued refining the formula, and in 2010, a specially prepared version called the Veyron Supersport, running a more powerful engine and a modified aerodynamic package, allowed racing driver Pierre-Henri Raffinel to hit that staggering figure of 431.072 km/h, a record certified by Guinness World Records as the fastest production car on the planet, a title that stood as a landmark achievement for years afterward. To put that number into human terms, the car was traveling faster than the tip of a helicopter's rotor blade sweeps through the air. At that velocity, the tires, custom-built by Michelin specifically for the Veyron because no off-the-shelf tire could survive the forces involved, were rated for only a matter of minutes at maximum speed before they risked catastrophic failure from heat and centrifugal stress, which is part of why Bugatti equipped the car with a special key that had to be inserted to unlock true top speed mode, a physical safeguard against a moment of reckless curiosity from an owner who might not fully grasp what they were unleashing. This was a car so extreme that Bugatti built entire protocols around the ritual of simply reaching its outer limits safely. The resolution of this story is not simply about a number on a speedometer. It is about what that number represented, a demonstration that the walls separating outrageous, almost fantastical performance from everyday, comfortable usability could be dismantled if engineers were given enough resources, enough time, and enough stubborn ambition. The Veyron proved you did not have to choose between a race car and a Grand Tourer, between violence and elegance. You could have both bolted into the same chassis, humming beneath the same leather-lined cabin. It inspired a wave of hypercar development that followed in the ensuing decade, with manufacturers like Hennessy, Koenigsegg, and eventually Bugatti's own successor, the Chiron, chasing the same horizon the Veyron had first reached toward. The Veyron's own top speed record would eventually be surpassed by other machines built specifically to chase that title, but the Veyron's true legacy was never really about being the fastest forever. It was about being first to prove that human engineering could bend physics into a shape it did not want to take, that a car with the power of a Formula One machine could also idle gently outside a hotel, its exhaust burbling politely, waiting for a valet. So when you picture that number again, 431 km/h, remember it is not just a statistic. It is the sound of a small group of obsessive engineers looking at the limits of what a road car could do, and simply refusing to accept them, proving, in one violent, beautiful blur down a German test track, that humans really could beat physics. Thank you so much for watching this episode of TrackTales. If you love stories about the machines, the risks, and the human obsession behind motorsport history, hit that subscribe button and join us for more racing stories, because this is only the beginning of the road.